Inequalities and interval notation. Very often in mathematics, we need to express a range of numbers. For example, we may need to express the solution of an inequality such as 3x plus 7 is less than or equal to 34. Let's solve this. Take away 7 from each side. Divide each side by 3. X is less than or equal to 9. This is one way of expressing a range of numbers. If we look at that on a number line, and we have the 9 here, we do a filled-in circle because this is a less than or equal to, so 9 is included, and then we do an arrow going off in this direction, as any value less than 9 is also a solution. We can express that with interval notation as such. We go negative infinity to 9. The 9 needs a square bracket because it's included. Had the 9 not been included, it would have been negative infinity to 9 with a round bracket. We must always have a round bracket on a negative infinity or an infinity because they are not numbers and therefore cannot be included. We may need to find the allowed values of x that can be input into the functions shown. We can't have negatives under a square root, so we need 5 minus 2x to be greater than or equal to 0. We're okay to put zeros under a square root, but not negatives. Subtracting 5 from each side gives us negative 2x is greater than or equal to negative 5. Then when we divide by negative 2, we need to reverse the inequality sign. And we get x is less than or equal to 5 over 2. So it's very similar to the example with the 9. We've got 5 over 2 here. It's included, remember a blank circle if it wasn't, and then extending off to the left. So this one will be negative infinity 5 over 2 with the 5 over 2 included. We're going to look at some more examples of interval notation as we work through some examples.